Hi there. This is a preamble to a multi-part video series on heated driveways. Uh, First off, uh, having built my second house, I did not want a heated driveway to begin with, but I was pressured by my wife and a friend to put one in. Having a historical construction background in concrete and pool construction, along with a lot of plumbing, electrical, and gas DIY projects, I decided to look into it and see if it would be a feasible project. What I've learned, what I would change, and what I don't know still, I will cover in this series. I think it will be informative to anyone who's thinking about doing it on their own. It's not a very hard project to do, but it's time consuming and there is somewhat of a cost. I started my search on YouTube looking for heated driveway videos to see what was out there and what could give me some help. There are a few, but they progress fairly quickly and it's very confusing, and some aspects go into a great deal of information depth that really isn't of much use to your average DIYer. So first we have the build, which there are various ways to accomplish this. Basically, you want to have enough concrete, that's what I used, but you want to have some type of insulating underneath. There's different products out there. I chose to go with hot rock panels because it was easy to put the PEX into it, and it gave me a good deal of insulation underneath of the concrete, so there wouldn't be a great deal of heat loss, and hopefully that would reduce the gas consumption during the heating process. A proper base and proper grading is essential to having drainage on the driveway. Having accomplished that, the laying of the hot rocks panels is quite easy, and the tubing placement, time consuming. It's nice to have 3 people do this. It just takes time and is not that difficult. I chose to run it into my garage, which I drilled 16 supply and return holes out through the foundation, and spray foamed around all pipes leading to the concrete driveway, and then also supplied an additional line that I would run my thermostat into the driveway about 15 feet. I laid out the piping runs on a scaled drawing I used a spiral counterflow design, figuring that I would have a hot line beside a cool line throughout the entire driveway. Whether this is good, bad, or the other, I don't think it really matters. I think flow through the piping is probably more important, which I will come to later on. The easiest part of the system was probably the actual build of the driveway itself, with the piping coming back to the manifold, which in my video on build is shown. I, with a 1919 square foot driveway, decided to use 8 separate runs of approximately 300 feet in length each. I used 3/4 inch PEX, which allowed me to go out as far as 300 feet. I could have gone longer, but that's what worked out best for my design and my system. The volume of my system with 8 runs at 300 feet, plus all the piping and all, I calculated to be roughly 50 gallons. And during the fill of the system, it actually turned out to be a little bit less than that. I purchased 25 gallons of 100% propylene glycol, which I diluted 50%, so I diluted it with water in a 5-gallon pail and filled the system with a sump pump, and I had roughly about 4 gallons left over. The third video in my series, I will show you the heating system and the plumbing that I did with the pumps to run the system, and some of the controls I chose to use. One of the biggest concerns in looking at some of the YouTube videos was one particular fellow who did a design and constantly insisted that the concrete shouldn't be heated up quickly, but never really gave us time frame or volumes or temperatures as far as how to heat the concrete or what he actually did. His was a manual system, which for most of us, I think we want some degree of automation. So I'm not sure how valid or how I'm not sure how pertinent his way of operation may be to most people. It really didn't help me out. I asked him multiple questions and he was very reluctant to give me any type of answers whatsoever. But using the adage that we don't want to heat the concrete up quickly, I took that in mind. So my hydronic design is based on, first of all, limited space in my garage and minimal cost. I used an on-demand Navien 210 that'll supply 188,000 BTUs per hour. There's a 240 that'll do 210. I thought I had purchased that one, but I in fact only bought the 210. Which turns out to be more than what I really need, I believe. That being said, I've yet to have my Navien 210 running at max. So far this winter, it hasn't been a problem. Usually it tops out at about 120,000 BTUs during a heavy startup, or if I increase the temperature of the output of the heater, which is a nice thing that I can do. Generally, the output of the hot water tank is around is between 40 and 90,000 BTUs. The key components of my hydronic heating system are an air release valve, a pressure tank and gauge, shut-off and mixing valves based on the theory of closely spaced T's. They're not so closely spaced, but I tried to incorporate that into my design. And then I also have shut-off valves that can be varied to allow different flow rates. And I also purchased a electronic controlled valve, which would be able to also control the different flow rates. I haven't installed that yet. And then I also have Wi-Fi controlled plugs that I can control the pumps automatically through my phone, which I can set to certain temperatures with probes that I have inserted in the driveway, as well as on the lines going to the driveway to determine what the temperature of the water is actually going out to the driveway. I also have, with the Navien 210, the Wi-Fi controller, which tells me exactly how much gas is being used down to the cubic foot, and tells me water temperatures in, water temperatures out, and it also tells me the gallons per minute of flow rate that is going through the heater. So I have a lot of control in it. I also purchased some, I also purchased a time delay relay, which I figured I could hook up to a secondary pump that could be turned on that would increase the flow out to the driveway, increasing the temperature so that I could have a ramped up system during heating. There are some systems or automated systems out there, particularly a snow detector, which I have considered buying. However, it only turns the system on when it's snowing. So if you're idling the system at 32 degrees, you roughly need to run it up to about 42 degrees in order to get it to snow melt. That's something that I have figured out through the use of mine, which no one really has put online. This is through trial and error, but that's what my system works at. So there is a 10 degree Fahrenheit increase that you need to do from 32 if that's what you're idling your system at in order to achieve snow melt. In order to do that, if you're going to do it slowly, and according to the one fella, if I do it as slow as he kind of mentions, it's going to probably take about 10 hours to get it up to temperature, which I find not feasible. So I've kind of figured out how to do it and get it up to temperature a little quicker than that, but to not shock the concrete. If you're going to let your concrete go down to minus 10 degrees or so, and then try and get it up to 42 degrees, it's gonna take some time, or you're gonna actually have to hit it with quite a bit of hot water to get it to go up there. Now, I have roughly 5.5 to 6 inches of concrete for strength, so there's a big heat sink there that I have to heat up during a heat cycle. I did go online and I happened to find one system that did use the weather reports and yada yada yada, that would look at all the information and decide when to turn your system on and off. However, that was a very cost prohibitive system, ranging somewhere around $3,000 just for the electronic component of it. And I think that was American money, which is probably about 4,000 Canadian, which I think was a little too much for me to pay. And who knows with weather reports how accurate it is. So right now at the moment I generally have the weather reports, which will give you an alert if it's going to snow in the next 24 hours, or you can just check it once a day during the winter or look outside and determine when you need to turn your system on. And at the same time, if it doesn't snow, you can turn it off. After installation of the driveway itself, which was in July, I let it sit for a while and never really got back to it until about October of this year, at which point in time I put the rest together, ran the gas line out to the front of the garage, and plumbed it all in. There were some design changes in my plumbing. I started off with one pump, which I felt probably wasn't sufficient, so I added a second pump, being a little bit on the cheap side, I guess. I don't think I really bought the correct pumps that would give me the flow, so I've now purchased another pump, which wasn't really that much more. I'm hoping it'll give me a little more flow, but that being said, the pumps that I have on it currently do the job. I just feel that I need a little more volume flowing through my system, as I have 50 gallons of glycol solution, which, if my flow rate, I believe, is running at about 6 to 7 gallons a minute, maybe 6 gallons a minute. It takes roughly 8 to 10 minutes before I can cycle the whole glycol system through the driveway, which I'm thinking is a little too long. At the far ends of my loops, that's where I notice there isn't as much snow melting going on. So I feel if I was flowing the heating solution through quicker, it may be a more uniform heat. I went on to the internet and did some searching as far as flow rates went, and one of the articles I came across was that it really didn't matter the flow rates, is that the heat distribution or the heat expulsion of the pipes was the same relatively no matter what the flow rate was. You can go into the physics of it, you can go into heat loss and all that calculations, but in a nutshell, I'm going to do it, and I'll get back to you whether I think it's better or worse, and we'll go from there. Now, cost. I know everyone asks about costs, and I also asked about costs. And there's a lot out there. You hear $30,000, $40,000, $100,000. It's amazing what some people say about these snowmelt situations. First of all, the basic cost is your driveway. Okay, the concrete itself is going to be a fixed cost, so you're going to do that no matter what. So I think we might as well throw that out the window, not worry about that. The next cost is insulation. How much insulation are you going to put underneath of your driveway? That is a big question. Is it worth it? I've seen across the road a fellow put one in. He used about a ½ inch of foam insulation. I don't think that's very much. I spent the money and put 1.5 inches underneath. Just made it simpler for me to do, but it was a big cost. The piping and the insulation was $6,000 in my system. That was the cost of the material. Then I laid it and then had to put the piping in and do all that. So that was my labor, which we're going to say is nothing. So the driveway itself was an extra $6,000. Then it comes to the hot water heating system. I chose an on-demand hot water tank. I'm not quite sure what the difference is between a boiler and an on-demand hot water tank. A boiler generally is much bigger. I think there's a little bit of a bigger reservoir in it. But generally it has to heat the water up at the same rate because we're cycling 50 gallons through the system in 10 minutes. So it's got to heat up 50 gallons within a 10-minute time frame. Actually, it doesn't have to heat 50 gallons up because I do not send my water out at 160 degrees. I only send the water out at I started off at about 60 degrees, and I might ramp it up to 70. I can go as high as I want, but sometimes I won't go much higher than about 80, maybe 90, no, not even 90 degrees, 80 degrees. So I'm not shocking the concrete. I'm not sending it out super hot, okay? We'll see what happens, okay? According to one fellow on the internet who has his dilution rates and all that, which is fine, but talking to the plumbers, everything I've heard is they're sending the water out at 160 degrees to the concrete. And I've gone on some other sites, and there is one where it says it would send it out at 98 degrees, okay? Most of the times when I start my hot water heater out, it's set at 98 degrees, and it's mixing with the 32 or 34 degree water that's coming in. So it's being sent out at 60 degrees to begin with, 66 degrees, and then as it cycles through, it increases, but only to about 75 degrees. But it does take a couple of hours to heat the driveway up, doing it slowly. With my on-demand hot water heater, the one thing that I like about it is that I purchased a Wi-Fi controller, which gives me a lot of information as far as what's happening, and a lot of control with my phone so that if I'm not around, or my wife calls and she says, hey, it started snowing, I can turn the system on. So I have a lot of control that way. I also purchased some Inkbird plugs, which are used for heating aquariums. And you can set the temperatures to a low and a high, which is proved to be very useful as my probes in automating the system. I'm very happy with the degree of variability and the ease of use of the system. How it makes it relatively easy to run it from my iPad or my computer or my phone, and I think that's worked out quite well. I have some tweaking to do with it, which is constantly in the works, in order to get it so that it runs more automatically. So getting back to costs, the entire driveway has run me around $10,000. $6,000 of it being for the piping and the styrofoam insulation, and another $4,000 for the hot water heater, the controls, the glycol, and the pumps. The gas line as well is included in that $4,000, as well as the copper pipes and fittings, of which I did everything, so I'm not including any labor into this. I had to run a 1-inch line from my basement out into my garage about 70 feet in order to get the supply, to supply enough gas to the hot water heater. So the base cost, without the PEX pipe and the installation on the driveway, is roughly around $4,000. That's with an on-demand hot water tank rather than a boiler. A boiler, I think it costs you $4,000 alone. They're quite large. So that's the one thing that one of the fellas on YouTube had, and it seemed to work quite efficiently and well for him, so I decided to go that route. And I didn't really see any difference as to why I couldn't do that. Time will tell, and we'll see what happens. In my second video, I will show you the heating system and the plumbing design and system after the manifold, and how I built that and how it's changed and what I'm going to change, what I've decided I'm going to change on it, to see if I can't get the system working better, although it's working quite fine the way it is. Getting back to costs, surprisingly, it has proven to be relatively cost effective in keeping the driveway cleared. Because I can monitor, and because the Navien Wi-Fi unit tells me exactly how much gas is running through the system, I've determined that to cycle it at an idle temperature of 32 degrees or 33 degrees during -1 or -2 costs me about $2.50 a day. Sometimes it doesn't even cost me that much. And during a snow melt condition, I started off every time I would turn it on sending $30 to my gas company. I ended up with credits. Credits. And I didn't even have to pay for gas to heat my house. So I scaled it back to $20, and I think that's even going to be more than enough. I factored in a $25 rate to run it per month, to idle it, and probably maybe $10 during a snow melt situation. And one of the problems is when we get into a long-term snow situation where you may have to have it on for 2 days, keeping the driveway at 41 degrees. That's where we're going to use a little bit of gas, and it's going to use some money. But realistically, it's not as much as I thought it was going to be. Someone said it's like heating 3 houses. I don't know what they're using. They're wrong. Mine's nowhere near that. Basically, I'm running my driveway and heating my house for free. And even then, it's not costing you that much if you want to look at it that way. So that way, I'm very pleased with. Now, maybe that has to do with all the insulation I put underneath of it. I'm not so sure. But I'll keep everyone updated, and I will have a running figure for the yearly cost, and I will update that too. It may be more, I think, though it's a toy, and if we look at it as a toy or a hobby, if it's $1,000 a year, that's not unreasonable for kind of a hobby where you don't have to shovel your driveway and you can turn it on whenever you want. So I don't think it's going to cost that much, but I could be wrong. Oh, I did not run piping onto my front porch steps, so I'd still have to shovel those. And don't sell your snowblower yet, because I still needed my snowblower once this year to clear the snow at the end of the driveway after the snowplow went by. But that was 5 minutes, and not so bad, as I watched my neighbor down the street who has his snowmelt system, and they were shoveling the end of their driveway. So you may still want to keep your snowblower. Don't give it away, even if you have a snow melt system. I put extra loops down by the end of the driveway so that perhaps I could melt that snow, but there's just, when the plow goes by, there's too much snow there. And if it's not on the driveway, if it's still on the road, you're going to need your snowblower to clear a path for your vehicle out of your driveway.